Okay, now let's look at another example with fractions with unequal denominators. So we have 3 over 7 minus 1 over 3. So we have to derive the least common multiple here. So both these are prime numbers. So the least common multiple will be 7 into 3, which is 21. So 7 times 3 is 21. So 3 times 3 is 9 minus 3 times 7 is 21. So 1 times 7 is 7. Okay. So we have 21, 9 minus 7 is 2. So can we simplify this further? No. Can we the only number we can divide this by is 2. Can we divide this by 2? No. So we leave this as it is. So now let's take another example of fractions with unequal denominators but mixed numbers. So let's take 2 and 5 over 8 minus 1 and 5 over 12. So there are two methods we can do this. First, let's look at one method. So one method is you first deal with the whole number. So 2 minus 1 is 1. Then all you have left is 1, and then you have 5 over 8 minus 12 over 5. Okay, so let's go another step. So now we have to come up with the common denominator, which is the LCM. So what's the LCM here? So let's take 8 and 12. So 2, 4, 6, 2, 2, 3, 2, 1, 3, and 3. We have 1 here and 3. So 2 into 2 is 4. 4 into 2. Sorry about this. You have 1 here. So 2 into 2 is 4. 4 into 2 is 8. 8 times 3 is 24. So 24 is the common denominator of the LCM here. So we take 24. So 1, the common denominator is 24. So 8 times 3 is 24. 5 times 3 is 15 minus 12 times 2 is 24. So 5 times 2 is 10. So now we have 1, 24. So 15 minus 10 is 5. So 1 and 5 upon 24. So this is one method of doing it. So we took the whole numbers separately. We did the mathematical operations on the whole numbers first and kept this aside, and then we moved on to the fractions. There is another method we can solve this. That is the second method is actually so this is how we solve unequal denominators with mixed numbers. Let's check another example. In that example, I will tell you what the two methods are. So we have 3 over 4 minus 2, 1 over 12. So first let's take the two whole so let's take the two whole numbers. 3 minus 2 is 1. So what's the least common multiple here? It is actually, so 4 and 12. What's the least common multiple here? 4 and 12. So 2, 2, 6, 2, 1, 3, and we have 3, 1. So 2 times 2 is 4, 4 into 3 is 12. So the common denominator is 12. So we have 12 here. 4 times 3 is 12. 3 times 3 is 9 minus 1. So we have the whole number here, 1 and 8 over 12. So can we simplify this further? 1, we have, we can divide both these by 4. So 4 times 2 and 3, right? So 1 and 2/3. So this is the first method of solving this. So next we will see what the second method is. Sorry, let me take this, write it again. So what's the next method? We don't take the two whole numbers separately. We make them mixed fractions. So how do we do that? So 4 times 3 is 12, 12 plus 3 is 15, 15 minus 12 times 2 is 24, 24 plus 1 is 25, okay, 25 over 12, Now let's get the common denominator. So we know the common denominator is 12. So we have 4 times 3 is 12, 15 times 3 is 45 minus, so 12 times 1 is 12, 25 times 1 is 25. Then we have the common denominator 12, 45 minus 25 is 20. So can we simplify this further? Yes. We can divide both these by 2. So we have 10 and 6. We can divide this again by 2. So actually we can divide this by 4. So we have 20 divided by 4 is 5. 12 divided by 4 is 3. 5 upon 3. Now obviously the numerator is more than the denominator. So what do we do? So divide 5 divided by 3 is 1. And we have a remainder of 2. So 1 and 2/3. So this is the answer. So two methods, but we got the same answer. One is to take the whole numbers separately. The other method is to make these mixed fractions and then do the mathematical operation and get the answer. So both methods result in the same answer. So it's your preference which method you want to take.